Hey everybody, Pete Meyer with Motor Age Magazine, and I'm here with Rick Dahman, Senior Product Analyst with the Timken Company. Now you know Timken as the world's leader in bearing applications. Today we're going to focus on one that we deal with every day in the automotive sector, and that's hub bearings. Rick, appreciate you taking the time to come out and hang out with us. Why don't you tell the folks out here what we need to be aware of when we're dealing with hub bearings and their service and repair.
Well, I'd love to, Pete, and thanks for having me. Today I'd like to talk a little bit about hubs themselves. Now, they seem pretty simple. You know, they're easy to change, but there is a few things that you can do that will ensure the lasting or the hub lasts as long as it should, okay, or maximize the performance of it.
Sure.
All right, so if we go to page 2, we'll talk about exactly what we're going to go over here. Couple key things: the proper axle nut torque, hub mounting bolt torque, and the wheel stud torque. We'll talk a little bit about lubrication, and I'm not necessarily referring to the lubricant in the bearing so much as what we as technicians do to help removal of the bearing again, so lubricant on the splines and stuff and on the hub flange. Then we'll talk a little bit about ABS sensors, and believe it or not, there are differences out there. So we want to highlight what you might find on the common vehicles. And then a little bit about seals. And what we're going to talk about seals there is what can happen to them if they're damaged during installation, and how critical they are to the hub assembly themselves. Okay? So if we go on to the next page here, proper axle nut torque. All right. One of the most common mistakes during installation of a new hub assembly is improper torque of the axle nut. Now, when I say improper, that can be too much torque or not enough torque. Insufficient or low torque values may allow the axle nut to back off. If the axle nut backs off, the axle nut is not only holding the CV shaft into the hub assembly, but on a lot of cases, it's actually maintaining the clamp or the load on the bearing itself. Okay, so what happens is if that axle nut backs off, that can't allow the components to separate, or the inner bearings to separate.
That's an interesting point there. I got to ask you about that, Rick, because I mean, when we think of the hub bearings, the advantage being, you know, they're a unitized assembly. It's all ready to go right out of the box, but torque is really that critical?
Torque is critical on, I mean, I don't know the exact percentage, but a lot of them. There
Sure.
are newer versions out there on some vehicles, and we won't get into this too much yet, but the generations change, where the hub actually maintains the clamp on the bearing. But on a lot of these, the CV shaft actually holds the bearing assemblies together.
Wow. Wow. Okay.
Okay? So I just want to highlight that of the returns, or of the, we call them alleged defects, that's the number one cause of alleged defects is the loss of axle nut clamp.
Loss of axle nut clamp, that's interesting.
Yes. Now the loss of it, like I say, will allow the cones to separate.
Sure.
Where if you have too much axle nut clamp, what you can actually do is deform the cones, okay, or deform the bearings themselves. So impact wrench is not a good idea. It's okay to use when you're removing the parts, but when you're installing the parts, I always recommend a torque wrench.
Sure, sure.
Okay, it's just a good idea. All right, so if we look to the next slide here, you'll see this is actually the outer part of the hub face where the axle nut would ride against. And what we're trying to illustrate here is you can kind of see the fretting on the face where the washer was contacting it. What happened to this hub assembly is this was excessive, where the nut backed off enough that the CV shaft was actually working back and forth on the splines. And you can see how it kind of fretted the face. It's almost like a metal transfer from the rubbing.
Yeah, yeah.
Okay, so this is a good indication here of, or it's a good sign, or it shows you how the axle nut, when it backs off, how much movement there can actually be.
Sure, yeah.
Okay. So now if we go to the next slide, you'll see the exact same hub assembly, it's from the back side or the inner side of the hub assembly.
Mm-hmm.
You'll see in the lower left part of where the CV shaft rides through there on the hub, you see how it's all chewed up?
Yeah. Oh, yeah.
That's where the axle nut backed off enough that allowed the CV shaft to be pulled away from the back surface of the hub, and it actually worked against the hub flange.
Wow.
And you can see how much damage it did there.
Wow. Yeah.
Okay, now this is an extreme example, but this is a bad case of the axle nut really loosening. Most of the time, it doesn't have to like be loose, finger loose, but it can cause internal damage that we don't see on the outside.
Well, if I recall, Rick, I mean, we did another project not long ago on hub bearings, and if I recall, when you're checking just the end play, that spec was I mean, really small. It was like 4,007-inch total movement.
Right, and that's on the extreme side.
Yes.
Most of these bearing assemblies, when you put them on, they're actually in preload initially, okay? Which is where there's actually it's less than 0 thousandths of end play.
Gotcha.
Okay, so it's mechanical preload. Now, as they wear a little bit, or as the assemblies are run, that's why we recommend the 4 thousandths. If you're checking a hub assembly to see if it's too loose, that's where the 4 thousandths comes into play. And it depends on whether it's a ball hub or a tapered hub,
sure,
as to how that clearance will affect it.
Sure.
Okay. All right. So if we go to the next slide here, what we're looking at is how I talked about if you lose axle nut clamp or CV shaft clamp, it can allow the inner raceways to separate.
Yeah.
When these hub assemblies are made or manufactured, the setting is actually it's almost like when you put a solid spacer on a pinion, where the cones are actually contacting the face of each other, and that's what holds that clearance, or that's what sets that internal clearance. If that axle nut backs off, it can allow those cones to separate, or that inner raceways to separate. And as you can see here in this photo, you see where the spalling is right at the inside edge?
Yes.
Midway on the cone there. And that's not actually where this is a ball cone assembly. That's not actually where that ball was designed to run.
Sure.
What's happened is it's allowed it to separate. Now on a ball, as in this photo here, you can see where it just ran in a non-designed surface. Or on a taper, if you allow it to separate, it can actually cause misalignment. It'd just be like having, if you set up your old TTS system and had too much end play in there, what it can do is it will allow the contact to be on the wrong side of the roller, or on one edge of the roller, which causes high stresses.
Sure.
Okay, and this is the result of high stress on a ball bearing. Now, another indicator that we see when we lose axle nut clamp is these cones are pressed fit onto the hubs, which helps to keep them from rotating, okay? When you lose that clamp and you start inducing a load pattern in a different surface, you can cause the cone or allow the cone to rotate on the shaft. And you can see the kind of fretting on the ID of the cone there.
Oh, yeah.
That's an indicator that cone was actually spinning on the hub.
Now that's a good question. I think a lot of techs might have. If you have a case like this, so you're coming behind this and you're performing the service, what about the I guess what that's riding on, that inner race is riding on what?
On the hub itself.
Right. So that's all part of the assembly, or no?
Yes and no. Okay. On a package bearing with 2 flanges. Then yes, it's part of the assembly. Now, on some of these smaller vehicles where you actually pull out a 2-row assembly,
sure,
the hub is separate, and a lot of times you don't replace the hub to reduce the cost. All you replace is the bearing.
Right.
But what I want to illustrate there is if you see that blackening or that fretting on the raceways,
yeah,
you should check the hub surface to make sure that it's not worn.
Absolutely.
Because those hubs are not hardened.
Oh, okay. So sure. So they're not hardened. They should actually probably take more of the beating then, huh?
Actually, they do. Yes.
Okay. Yeah.
Okay. It's just like if you ever, well, I mean, not the old 2TS system, you know how when they spin, it actually wear on the spindle itself?
Yeah.
The same thing can happen on a hub assembly. It's
Same
harder to notice. Okay, so if it reduces the size, it will not, if it wears on the hub and reduces the size, then of course the clamp effect will not be there. The fits are not there to help keep that hub or that cone from spinning on.
Gotcha.
Okay?
Yep.
All right, let's move on to the next section here, lubrication. And we'll go to the next slide here. What I'm really talking about is lubricant on the hub bearing itself, okay? Now, I know you're in the south, I'm in the northeast. I use a lot of Neverseed. Okay? If I ever want to get something apart again, that's what's required.
Sure.
I don't recommend it, or we don't recommend it on the CV shaft itself, the splines or the base where the CV contacts the hub. And the reason we don't is if you put, and I say excessive lubricant, but it doesn't take very much. If you put too much lubricant on there, whether it be grease, oil, or anti-seize type stuff,
sure.
When you press that spline into the hub itself, you know, it's just like when you there's no clearance in there, or very little clearance in there, so the lubricant is going to be squeezed to the back. And if it gets between the CV shaft and the hub, when you torque that up, there can actually be a hydrodynamic film in there.
Uh-huh.
That will give you a false reading, meaning that you'll get the torque on the axle nut, but because of that lubricant film there, it will not maintain that torque. The lubricant will eventually wash away or fall away.
Yeah.
And now you've lost your preset for your plant.
Yeah, and I gotta interject there. I think a lot of times when manufacturers encourage us not to use some of these products, it's not so much the product itself that's causing the issue, but it's just a trend, or I don't know what the right word would be.
A result, yeah.
Well, it's the old thing: if a little's good, a lot's better. And
right.
I think that's where a lot of times these type of products have an issue. Is not so much is the fault of the product as it is the technician applying the product in excess.
Absolutely.
You know, so I understand that. You know, that you have to make sure that your product delivers the service it's designed for it and is capable of, you know, when it's installed properly. So, you know, guys, you know, when you're doing these jobs, you know, keep that in mind. It's recommended by Timken, as he just said, not to use these kind of products. But if you're in those northern states and you need to get that stuff apart again later, you have to use it sparingly. You need very, 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 very little, you know, of any of these products to do what they're intended to do, and as a supplement. So.
A little goes a long way.
Yes, sir. That's an old hair stuff from years ago. That's dating me, so we'll leave that go. A little dab will do you. Yeah.
Yeah.
Okay.
All right.
Yes, sir.
So that seems pretty clear, right?
Oh, yes, and I believe you have a good slide of it coming up too.
Yeah, the next slide here shows exactly where the buildup can occur.
Sure.
Okay.
Yeah, right.
So when you're pressing that CV shaft in there, it's going to force the fluid back. It's not going to want to go through the splines. You know, they're too close of a fit.
Sure.
And a lot of those actually have a helix to the spline, or a slight twist, and that's so when the CV shaft is in the hub, it doesn't have that rattle, you know, that back and forth rattle. It tries to take that up. It's almost like a really slight twist, or bands on an arrow, or
yeah, sure. It's kind of like almost like a worm gear, but not quite so severe.
Right. You can't even see it. You'll notice that when you press the CV shaft in, or when you put the bearing assembly on, it'll go about 3/4 of the way, and then all of a sudden it'll get tight. You know, and that's what's happening. That helix is taken into effect, and it's tightening those splines up, so you don't get that rattle in the wheel.
Gotcha.
Okay, and every hub assembly is different as to what that helix is. It depends on the manufacturer and what they specify.
Sure.
Okay, so just use a clean everything off you can with a wire brush, you know, a little piece of emery if there's any kind of buildup. on the CV shaft itself. Just make sure there's good contact surface there.
Gotcha. Mm-hmm.
Okay. Now we'll go on to the next section here. We're going to talk a little bit about sensors and just some things to look out for. Okay, so if we go to the next slide, we'll talk a little bit about, there's two basic kinds of sensors in the automotive world. There's active and passive.
Mm-hmm.
Okay, passive is the original design, we'll say. It's almost like a Briggs and Stratton, or I hate to advertise for anybody, but like a magneto system,
Mm-hmm.
where you have a magnet next to a target wheel, and as that target wheel spins, there's gaps in that target wheel.
Sure.
It creates an electrical signal that goes back to the computer.
Yeah, and used in a variety of applications, not just the wheel speed sensors.
Absolutely.
Mm-hmm.
Okay. The restraint on that was that it took movement to create that signal.
Right.
Okay. So for ABS brakes, it works great because you're generally moving when you apply the brake, and it can still see the wheel moving.
Mm-hmm.
But for when the factories or the auto manufacturers wanted to include or to use that for either engine management or traction control, they needed more sensitivity to that.
Yeah.
Okay?
Mm-hmm. Sure.
So that's where the development of the passive or the active sensor came out. Okay, the active sensor actually has a little computer chip in it, and the engine computer or the vehicle's computer actually sends a signal down and reads a sine wave. It gives you much lower speed capability, meaning that it basically at zero or slight movement it can read.
Right.
Okay, so it was better for engine management and traction control type systems.
Sure.
Okay, and this leads us on to our next slide. This is just a little, believe it or not, I had this question before. If I buy a bearing assembly, the sensor doesn't plug into my truck, can I change the sensor or just splice the old plug into my new sensor cord so it will plug into my truck? And hopefully we all know the answer to that is definitely not. Okay? The reason for that is if the sensor connector differs from the one that you were replacing on the vehicle, okay, this may indicate you're trying to replace an active with a passive sensor or vice versa.
Mm-hmm.
Even if the connectors were the same, it is never recommended that you splice the old connector onto the new one. So never cut that wire. It's calibrated. You know, that resistance is already factored into the computer, so it knows that.
Yes,
and
sure.
if you start cutting and splicing, it will not work as intended.
But I say if you pull it out of the box and you have the wrong connector on there, then odds are you got the wrong part.
That's exactly
Yeah,
right.
you need to call your part supplier up and say, hey, this is wrong. I can see where some do-it-yourselfers would do that and not understand the consequences. Hopefully the professionals know better. Yes, and like you were pointing out, you know, the act of splicing that wire together can increase resistance. And on some of these active speed sensors, that's going to change the signal. You send the customer back out, and now they have ABS and TCS issues when there shouldn't be. So, and the computer doesn't know. The computer's not going to know. This is the signal it's seeing. It's assuming that's what's going on. So it can be very difficult to pinpoint that as the issue. Yeah, very good.
That is correct. And I have seen that before where they have changed them. But that's the reason for the connector changes, to illustrate that there is a difference and generally the change was started in around 2005 by some manufacturers, and it can go as late as 2007 for other manufacturers. So anywhere in that time frame, that's where you should be looking for this. If the sensor doesn't plug in, there's probably a reason.
Yeah. So make sure you have a good parts guy and you have a good part.
Absolutely.
The problem.
Okay, you know we all know how the big three or all automotive manufacturers are. They'll run over in production. So, you know, even though they said 2007 was a changeover, they might not have changed till 7.5, you know.
Exactly. Yep. Yep.
So it's just something to be aware of. Okay. So if we go on to our next type of sensor, which is active sensor bearings, or ASB, magnetic encoder seals, we're going to talk about. Okay. The encoder is always embedded into the seal, and it typically has smooth brown surface, but the color may change. Now, what you're going to see, and this is mainly on the 2-row assemblies that you can install either direction where you're pressing them into the knuckle.
Mm-hmm.
Okay? What you want to look for is if you have an ABS sensor on the vehicle's wheel, and it should be located somewhere in the knuckle, then you should check the bearing, first of all, to see which side the sensor is located, and second of all, make sure that it actually has a sensor or a magnetic encoder seal on the bearing. Okay?
Right. Oh, yeah. Yeah. It's an easy mistake to make because I made that mistake a few years back. Very easy
Absolutely.
to make.
Absolutely. So, a little trick. The easiest way to check for a sealed encoder is if you don't have, and most of us don't have this magnetic encoder detector, but we usually have some kind of metal laying around, something light metal like a paper clip.
Sure.
I've actually used a metal scale or a little metal ruler,
Mm-hmm.
and it will stick to the sensor or the seal that has the encoder embedded into it. Okay? Now, it's not going to pick up bolts and nuts off the floor, but you will feel that magnetism.
Yes. Mm-hmm.
Okay? So that indicates that side should go towards the ABS sensor. Okay?
Mm-hmm.
So that's all the next slide is, just make sure that you check for orientation when removing and installing these 2-row assemblies. Okay, now most of the hubs with flanges, bolt-on flanges, that's already figured out for you. So you only have one way to put that on.
Sure.
These are more the 2-row hub assemblies.
Sure.
The bearing assemblies. Okay, does that sound pretty clear?
Yep.
All right, if you'd like, let's go on to, we'll talk about seals a little bit, not so much design or anything, but what can happen to them when we're installing them.
Okay, and that puts me on the first seals page.
Okay. All right, so one of the things that I want to highlight is one of the most important components in a sealed hub and bearing assembly is the seal. All right, that's the most fragile. That's the one that has to do, I won't say the most work, but it actually does 2 jobs. Okay, it keeps the lubricant in the bearing, and it prevents outside contamination from entering the bearing assembly.
And I think that was an interesting point that we talked about on the tapered bearings too, Rick. I don't know how many guys realize that we always call the little dust cap, on those the tapered bearing service, and I didn't realize how important that thing had as the job as a seal,
Right.
So yeah, that's it. I think that's a point worth reiterating to everyone watching the video, that not only is it keeping that grease in, but it's keeping all the bad stuff out.
That's correct. And one other thing I see once in a while is, when we create or we manufacture these bearing assemblies that are sealed and preset, pre-greased, there is a certain amount of grease that we put in there.
Uh-huh.
Now, I know everybody's tendency is to, more is better, but here's another case where taking the sensor out of the hub assembly and pumping the hub assembly full of grease, you're really not benefiting yourself.
Wow, I didn't know people did that.
Yeah, I've actually seen them where, the hub assemblies where the sensor is screwed into the hub.
Sure.
A little bolt that holds it.
Yeah.
I've seen where they take that sensor out and they put a grease fitting on there and they pump the bearing full until the grease is coming out of the seals. And it's not a good idea.
Oh my. Well, you heard that here, guys. If you're doing that,
which leads us to,
stop.
Yeah, please don't. I mean, I understand that you want to flush the contaminated lubricant out, but there's just no way to do it and without ruining or shortening the life of your bearing assembly.
Sure.
It can create excess heat and churning. You'd be surprised at how little lubricant a bearing needs to operate efficiently. All right, so that brings us to our third point here is when we're installing these assemblies. Now, the bolt-on hubs are a little safer, but
Sure.
the 2-row units, you must be careful when you install those, when you press them in. If you damage that seal during assembly, that bearing is not going to last very long. You've just ruined one of the components in there.
Sure.
Okay? So if we go to the next slide here, this is just an example of a seal that made contact with the rolling elements. And I was trying to highlight there. You see how they're spaced evenly around there?
Yes, you can see that.
And that indicates that they contacted the rolling elements inside the assembly. All right, now what can happen is when you're pressing on this bearing assembly, if you distort that seal or press it in a little bit farther than it was originally intended, it makes contact with moving parts inside of the bearing assembly, and it can ruin that seal then.
Sure.
Consequently, it will not last very long. You won't notice it right away.
Right.
But it will not last very long.
And I think that's a good point here too. I want to interject. I mean, even when you do make these mistakes, you know, the bearing's not going to fail like in a week. You know, but a bearing is designed to run however many thousands of miles that they're capable of is going to be shortchanged. You might only get half that, 3/4 of that, a third of that. I don't think there's any crystal ball to know for sure.
Absolutely not.
But as a professional technician, you need to be sure you give the customer what they're paying for. They're paying you good money to do the repair. They're paying good money for the quality parts. And you want to do everything you can to make sure that they're getting full benefit of the money they're spending.
Absolutely. I mean, that's a sign of a quality shop.
Absolutely.
I agree. All right, so if we go on to the last one here, what I was trying to illustrate here is, I mean, it's kind of hard to see in the picture here, but at the top of the bearing assembly, you can see kind of a change in the look of the seal. And this bearing, the seal was actually distorted or damaged during installation. And it doesn't look bad here, does it? No. I mean, you really don't see much damage here, but until you look at it and try to see the plane where it actually dips in, and that little bit of distortion will cause that to leak.
Sure. And let me guess, somebody used the drift to put that in.
I couldn't tell you whether they used the drift or they just didn't use...
Tapped it in with a hammer?
Correct.
Yeah.
Correct.
Yeah.
This one is actually an axle bearing. It's a direct on that's used on a solid axle out on a wheel end. And I know how people, we like to drive those things in there. They are a tight fit. There's no way you can press them in there. You have to, unless you pull the whole axle assembly out, and I'm sure 99.9% of us won't do that. So you have to be careful when you're pounding these assemblies in there.
Right, absolutely. Use the right tool for the job.
Absolutely. Okay. So that's all I had for you today. Do you have anything that questions or concerns?
No, Rick. I really appreciate you taking the time out this morning to hang out with us and present this information on the proper care and service of hub bearings. I know everybody out there is going to learn from it. I did. I'm sure there's pointers there that we can all take back when we're servicing these type of bearings for our customers to do the most professional repair that we can. So thanks again, Rick, for coming out and hanging out with us.
Hey, Pete, I really appreciate you having us, and I love to talk to you guys.
Yeah. And to everybody who watched the video, thanks for taking the time to watch. Be sure to leave your comments in the comments section and join us in the Auto Pro workshop for a lot more information just like this.